I am still on practice set 3, but this time we're looking at the exponent section. And I'm not sure why it has number 1A, but that's just the number, so you can ignore that A. This problem is a long list of 9s. There are 9 of them, to be exact. And I'm going to work this one the long way, just to remind you how this works, and then we'll shorten these. So you can fast forward if you want to. 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it says to write the exponent expression and calculate the powers. So the base is the 9, because that's what's written so many times. How many times is it written? It's written 9 times. So that's the exponent. And we are about to find the power. Now, if I were doing this on a test with a calculator, I would not do it this way. I would type all that in my calculator and write it down. The thing I want you to know is that this is not 81. It's not 9 times 9. So here we go. I'm going to take the first 2 of those and multiply them. And you see that I get the 81 right there. Then I bring down this next one. That's going to be 729, I believe. Let me do it on the calculator. Yes. Then I drop the next one. 729 times 9 is 6561. Then I bring down the next one. Again, on a test, I am not going to do this. But my job here is to show you what this means. So if you do a couple of these, you will remember what it means. I'm hoping my calculator can handle this problem, because it is huge. Exponential growth generally is very, very large. If you have an exponent that is a 9, things are going to get big fast. So here's this 9, and I'm just hitting 9 on my calculator. I'm going to do it one more time, and this will be a good chance for us to practice reading a number as well. So here we go. There's that 9, and finally we can stop, and here's what I came up with. Now, you may have noticed that I don't use commas when I'm doing math. That's because I tend to get them confused as decimals. So I'm in the habit of leaving them out, but you can definitely use them if you want to. So starting after the 6, that's where the decimal point would be sitting, we're going to put a comma here and a comma here. So this number is read as 258 million. Let me just write it out. And after you say million, you notice there's a comma in the number. 258 million, comma, 280 is in what section? Thousand. And there's another comma. 300. And then anything under 100 gets hyphenated. Notice I have not used the word and anywhere in here. The only time you can use the word and is for that thing right there. The decimal point is the and. Okay, now we're going to just shortcut the rest of these because that was way longer than we need it to be. So 2a, I have a base of 64. So let's count the number of times right there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 64 to the 9th power. Now, here's the problem. I'm used to a scientific calculator where all I have to do is hit one button. But this calculator, you have to literally count them out. So be careful. Put in a 64, there's 1, times 64, that's 2, times 3, times 4, times 5, times 6, times 7, and I get an error message. So this particular calculator will not handle that number. That tells me that you won't have this one on the HESI practice test. If the calculator can't handle it, they won't give it to you. Okay, so 3A, this one it will handle. We have 4 to the 1, 2, 3, 4, 5, 6, 7, 8th power. So we just have to do all clear and start typing them in. There's one of them, 2, 3, 4, 5, 6, 7, 8 equals 65,536. That one could be on the test because the calculator will do it. Okay, 4, I have 100 to the 1, 2, 3, 4, 5, 5th power. So all clear. 100, 2, 3, 4, 5. On this calculator, I get an error. It just cannot handle that large number. It's not a scientific calculator. But that means you won't have to deal with any that large. This one we don't even need the calculator. It's 1 to the 2nd power, or 1 times 1 is 1. 6A, I have 2 to the 1, 2, 3, 4, 5, 6, 7th power. We can do this one. So all clear. 2, 2, 3, 4, 5, 6, 7 is 128. Actually, I'm going to go ahead and bring this down here. Number 7, we have a base of 95, an exponent of 3. So we'll say 95 times 95 times 95 is 857,375. 857,375. And then 8A, we have 7 times 7, so that's 7 to the 2nd power. That's a perfect square. It's 49. 9, we have 1 to the 6th power. And I'll tell you, if the base is 1, the answer's 1. If the base is 1, the answer's 1. It could be 1 to the 6 million power, and it will still just be a 1. Okay, 2 to the 4th power is 2 times 2 times 2 times 2. That is 16. One other thing that I need to be sure, I should have told you this in class, but in case I forgot, let me put it right here. Any number, let me say it this way, any base to the 0 power equals 1. And I'm not going to go into the explanation right now. Just trust me. You could have 45 to the 0 power, and that answer will be 1. You could have 10 to the 0 power. That answer will be 1. If the exponent is 0, the power, the answer is 1. Okay, let's do the square roots. And I think I'll just let this video keep running and then I'll stop it. It tells me to find the square root of each. The square root of 25 is 5. The square root of 49 is 7. The square root of 100 is 10. The square root of 81 is 9. The square root of 121, if you don't know this one, use your calculator. 121 square root is 11. The square root of 400, again, use the calculator if you need it, is 20. The square root of 256, this is one a lot of people don't know, and that's okay. That one is 16, because 16 times 16 is 256. The square root of 1 is 1. It's its own square root. The square root of 169 is 13. And the square root of 9 is 3. Okay, that brings us to the end of practice set 3.